What's up, everybody? It's Brandon from Self-Made Fab. Today is going to be our first YouTube video, and I figured we'd show you guys how to build some wheel tubs. First, we clean up this mess, and then we'll get to it. So, wheel tubs we're building today, and this, what I'm going to show you guys today applies for pretty much any type of wheel tubs. Today I'm going to be building my raised bed floor C10 wheel tubs for a customer. So, you can either use CAD like I do, or the other CAD cardboard-aided design, and make yourself a template of how you want it to look, and you can mock it up on your truck. Or what have you. But the way I do it, I use CAD. I go off customers' measurements, and I will show you guys how I do this, and then I'll explain how you can do it if you don't have CAD and a CNC. You can do all of these with very simple tools. It just takes a little bit longer. I choose to do it this way. One, because I sell these, and I would like them to be precise as possible. So the CNC just helps replicate and speed things up. Also, it keeps distortion down in the metal, since we'll be bead rolling them, which causes distortion as well. So on these tubs, they're going to be 32 inches wide at the bottom, and they're going to be 9 3/4 inches tall. So we'll put those measurements in first. So on the height, I add 1 inch for my flange at the bottom of the tub to mount to the bed floor. So here is my outline. So first I'll add my flange at the bottom. Like this. And then I will draw my lines to start shaping the tub. Mirror that to the other side so it's the same. And we'll put a radius on it. I usually do between an 8 and a 12-inch radius to size, depending on the size of the tub. So I'll kind of look at it. If I don't like it, I'll just change it. I don't like it. So we're going to make it a little tighter. Go with an 8-inch radius. Like that. And then get rid of this. So there's the outline of the tub on the side. Set the cut layer, and then we will copy this. So we have 2, and then we'll save them. So my next step is to open up my sheet cam so we can make a cut path for these. All right, that's ready to cut now. So we'll go into Mach 3 and get this ready to cut. First, we need to cut the sheet in half. So the nice thing about having a CNC is I can just cut my sheets in half really quick. Of course I have a stomp shear too, but this is easier. All right, all ready to cut.
Soundstripe.
All right, so we got these cut out. Now I'll go ahead and lay them out, and then I'll show you how I get the top sized so that it reaches all the way around. 'Cause it's kind of hard to measure radiuses on the CAD for me with my old software, so I kind of do it the old school way. But first we'll lay this out. So we got a 1-inch flange down here at the bottom, and this will be for like the factory C10 wheel tubs. They all have, well, not all, but 60 through 72 all have mounting flanges down at the bottom of the tubs. So I make mine the same way so that they're easy to install for the customer and there's no welding involved. So there's my flange. Here's my first bead roll line. So I use an 1.25 yardstick for most of my perimeter bead roll work. It just makes it easy and accurate. And then a little trick I do on these radiuses, instead of trying to use that or a piece of tape or something silly, I've kind of just gotten used to, I'll line my marker up with my straight line and then I'll just run my hand like a pinstriper would. Like that. Then I'll find my center point, which this is 32 inches, so half of that's 16. I'll take my square, square this up. And then this will be my center line for when I weld the top piece on, that I can line it up. So, in this one, I use my self-made fab circle template. They're aluminum, they last forever, so if you need one, let me know. That one's done. That one's done. Alright, that one's done. Now, put it in the vise, hold it for me. And what I'll do is take a piece of tape, lay it out on the top like this, and then I'll mark my corners. Then I'll lay this out on my table like that. I'll measure my marks. I think it's going to be 39 3/4. So plus I'm going to add an inch for a flange on each side. So it'll be 41 3/4. And then I'm going to add an extra 1/2 inch for extra material so it doesn't end up being too short. So they give me a 1/4 inch on each side. And usually that ends up being perfect. Sometimes I'll have to trim like an 1/8 inch off, but I'll just take it over the stomp shear and shear the end off. So here's our top. So I gave 2 extra, an inch on each side, so 2 full extra inches plus a 1/2 inch, so I can get my flange all the way around. Also, on the back side towards the inside of the bed, there'll be another flange to mount to the bed side. So we'll mark that one first, which I make. Sometimes I make an inch if it's a big tub. That way it's a little stronger. For these raised tubs, I just make them 3/4 of an inch. So now I got the back flange marked at 3/4 of an inch. This flange we will break in my magnetic brake. There's our front or rear flange. Alright, so there's our main layout. We ended up being 42 1/4. Check it, just make sure it's right. We're right on. So now we'll read this. These corners. That. So next we find the center of this, and then we can start bead rolling. Alright, so now we're going to start bead rolling. I use a Mittler Brothers Jamie Jordan Signature Edition 36-inch bead roller. I've had this thing for, I don't know, over 10 years, and it's been great. Never had a problem with it. I honestly think it's the best bead roller on the market. Along I have Jamie Jordan Signature dies. I'm not even sure if they make these anymore, but they're Nylotron. Mine are pretty worn out, but they work pretty good still. Like I said, they're all over 10 years old, and for being plastic, they've held up pretty good. So on here I have the art roll step die, just because it gives me a little bit more view of what I'm doing, and then just a standard step die on the bottom. I also have a custom spacer. I have an adjustable top shaft, but not a bottom shaft. So I made a custom spacer for when I do reverse bead rolls, which is normally what I do on most of my wheel tubs and inner fenders. Basically, I raise this portion up instead of down. Most people will do it down. So I made this spacer here so I can make the bead fatter if I want to. So we'll get started with bead rolling this. What I like to do is I'll start on a flat section and I'll just barely come down and put any pressure, and then I'll start rolling. And then I'll gradually increase the pressure as I go until it starts making a nice bead. If this was a bigger panel, I would not use so much initial pressure. I would work it real slow and make multiple passes. But is this being only 10 inches tall and 32 inches wide, it's pretty small. So there's not much distortion. But I'll go over it another pass without increasing any pressure, just to get that bead in there good. And if there's any spots in the radius I kind of messed up, I can go back over them, clean them up a little bit. There's one. And I'll time lapse the rest. All right, now that we got those bead rolled with their step die, we're going to remove the step die and install, here's a little spacer I made. We're going to install the dies that we use to put a radius on the edge of our wheel tub for our weld seam. I mean, you could just butt them together and weld it with like a 90-degree, but I don't think that looks very good. I mean, if you don't have a bead roller or dies like this, then it's kind of your only option unless you buy a set of trailer fenders that have the radius on them. I used to do that a long time ago, but it's a lot cheaper just to make them from scratch. Alright, so now we're going to break our flange, our mounting flanges, for the top of the tub. This is a 48-inch Bailey magnetic brake. I've had it for, I don't know, 8 to 10 years or so, and it's been a great machine. It's pretty beat up, but it gets the job done. still. So I can't be mad about it. If you don't have one of these, I highly recommend getting one, because a lot of things you can't do without one of these, with a regular box pan brake. Alright, got that 90 degrees. Nice bend. Now we'll do this brake's really nice. So when I come back and I break these flanges on the ends, a typical box pan or sheet metal brake, you wouldn't be able to do that. You'd have to do that step now. But instead of having to figure out this angle and all that, I'll do this after the tub is done, pretty much. That way I can break it where it needs to be, and it's a lot easier. But having multi-piece dies really helps with just breaking that portion, because you're sticking it in and there's going to be a side here and there's a flange here. So on a typical brake, you wouldn't be able to do that. So go ahead and get this one done. There's our mounting flange along the side. So now what we're going to do is go over to the shrinker stretcher, and we're going to shrink this flange to match this profile all the way across. Alright, so now we're going to shrink this to fit that profile. So the way I do this is I'll just shrink a little bit at a time and check it on the side panel and make sure that my radius that I'm trying to create is following that. So the way shrinker and stretcher works is this one's the stretcher, this one's the shrinker. This is squeezing the metal in as you step down on the pedal, and then the stretcher does the opposite. It'll spread the metal apart, which makes it thinner. When you shrink it, it makes it thicker. So all the molecules in the steel, they're like a, I don't know, like a cluster, and the cluster gets real tight. So it gets, depending on how far you have to shrink it, it gets really hard to shrink, and the metal gets really hard. So when I'm done, I either run it through, depending on how bad it is. Normally, if I like these raised tubs, I don't have to do a big radius, but if I have to do a sharp radius, I'll planish. I'll take it through the planishing hammer and planish that back out. But these usually just a hammer and dolly in the DA works fine to smooth it out.
Sounds great.
All right, we got our flange shrunk to follow the perimeter. Pretty good. Now it got wavy on the weld seam edge, but I'll show you how we get rid of that. All right, so now we're ready to start welding. First time I ever built a set of these like this, long time ago. All this freaked me out. I didn't know what to do. I thought I should shrink it because it was all stretched out, but you don't have to do that. And I'll show you. reason that happens is because this edge is radiused. So really, where these are, they need shrunk. But we can get away without having to do that because they're not stretched out too far. So what I do is make sure I got a clean edge. And then I'm going to line up my two center marks that I made earlier when we did our layout. And I'm going to tack them together. So, what we're going to do, and this is all heavy, take our sheet metal hammer and lightly tap it into shape. Put another tack on here. When you do this weld seam, you want it to be as tight as possible, like without pushing it or being a big gap. Tight as possible, so that way you can use as little as filler wire as you can. And if the gap's big, it will cause more heat to go into it, so it'll warp more. So when you go to metal finish this, you're gonna have to hammer and dolly it a whole lot more. Which I try not to have to do that. When I build these, I have a lot of them to build, and time is money. So get them done fast and still putting out a quality product is what's the most important. Work my way out both ways. And I don't know if you guys noticed, but I only cut one top panel. The reason for that is when I do wheel tubs, especially ones that I've not done that size before, I'll only cut one top until I get one of them done, just to make sure that everything's long enough, which usually it is, but sometimes it is, and I'll end up wasting the sheet metal. So I do that just to prevent wasting. Up like this, kind of gives me more leverage to force this into shape. Whoop. So I just hammer that radius in. And then before I go weld it up, I'll hammer and drop everything flat. But we'll just keep on tacking here.
Soundstripe. 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 Soundstripe.
All right. So in the time lapse, got all this tacked, and I got these flanges broke in the brake. And you can see they were just long enough to give me that 1 inch. So all I gotta do is just fill in this little corner. So now I'm gonna go put a couple tacks in between that I missed and hammer this thing around and then weld it. When I weld this, I will start here and I'll go all the way to the other side with as least many stops and starts as I can. Sometimes I can do the whole thing, sometimes it hurts my back, or I fuck the tungsten up or something. But the less, like a lot of people, if you're MIG welding it, I would do like a couple inches. I would tack it every inch at least, and then I would grind those down, and then I would do every inch or two, and then cool it down with an air hose slowly, and then continue on and so forth. But when you TIG weld it, with my experience, you can start and stop and cool it down, but that just takes forever. And every time that you start and you stop, you're creating a warp, which, I mean, you could get out, but if you're doing what I'm doing, and you don't want to spend a ton of time, extra time that's not needed, I would just weld it all the way across with as least amount of starts and stops that you can. Especially when you get up into this flat area. This radius isn't too bad, and this leg here isn't bad, but once you get up here, if you start and stop, it's going to cause either the face to warp or the top to warp, which you don't want. So right now I'm going to work out this radius because it's kind of sharp. So I clamped it to the table so it doesn't move. It kind of, I mean, you could use a lead bag or something, which on these it's kind of hard to put it up here. So I just clamp it to my table so it doesn't move on me. And then I made a custom made dolly that fits up in here, that I can hammer this round, because it kind of gets a point from bending it over. So we're going to hammer that down so it matches this and this. Alright, now I got this pretty well tightened up to where I like it. So I'm going to go ahead, grab some wire, and weld this up. What I'll do is set it up. I get these short pieces of TIG wire off Amazon. I just like having smaller pieces to work with. So once I get close, I'll grab another one without losing arc if I can. And we'll get it welded.
Soundstripe.
All right, got it all welded up. See, I had a couple of starts and stops, but the heat affected zone pretty even all the way across. That's what you want. You don't want to see a bunch of, you'll know if you're not being consistent, you'll see a the heat effective zone will come all the way out to here. Another thing, if you do have to stop and start again, when you say, if you start here or stop here, you need to go back like a ½ inch and start over and bring the heat, as you can see I did here. That way it's not such a sudden change in temperature on how it affects the metal. So that's all welded now. So what we'll do before we do anything else, we'll cut our little pieces that go in here, just little 1x1 piece. This side I'll have to trim. This flange ended up being a little bit bigger than 1 inch. Yeah, so we'll get these pieces in, and then I'll show you how I metal finish all this and finish the tub up.
Sounds good.
All right, we got the corners welded in. Now we're gonna start metal finishing this weld and get this done.
Sounds good.
All right, so the way I metal finish these, just my 90-degree angle grinder, snap on, and we're gonna start with a 24 grit. Just lightly knock the top of the weld down. We don't want to get into the base metal. We just want to knock the weld down, and then we'll go to a little bit finer with a 60 grit, and then we'll go 80 grit. And then from there, we can DA it with 120.
Sounds good.
Ground down now. Now I gotta make it look a little bit better. I mean, I can leave it like that. I mean, you're gonna body work it and paint it anyways. But since I'm shipping these out to a customer, I'm gonna metal finish them just a little bit farther and clean them up a little bit. So here we go.
Sounds right.
Now, gotta DA it off. Hit it with some acetone, clean up all the Sharpie. And all the oils from my hands, because leave the oils from your hands and your fingerprints. The time it takes these to get to where they need to go, they're gonna have finger spotted rust prints all over them. So, try to clean them up best I can. And there's a finished raised bed floor wheel tub for a C10. I'm not gonna bore you guys with building the other one, but basically, like I said, I was gonna explain how you could do this without the tools that I have. A lot of the stuff you can get by without, but the easiest way, if you don't have a CNC or even a plasma cutter, is to make a cardboard template of your shape, you know, whether it's round or flat on top or a triangle. You know, you make your side template and then figure out the top piece based on your measurements, because I build all these off the length, the width, and the height of what the customer wants. and I sell quite a bit of these. I've been building these for over 10 years. I build roughly 1 to 2 sets a day on average, so they keep me pretty busy. But yeah, you can make your template of this piece and then this piece, and then tape them together with masking tape, and then transfer it on to a piece of metal, and you can cut it out with a grinder. You can get a set of electric shears from Harbor Freight, which are cheap. All those things, you know, or a handheld plasma cutter, which I don't really like to use because they're not very accurate. If you're not very fast with it, it will cause the panel to warp, which just makes a headache in the long run. So yeah, the easiest way without a CNC, I would say, is electric shears or tin snips. Depending on how strong you are, tin snips will work, but they'll give you some arm pump. And then as far as the bead rolling, you don't need a fancy bead roller. You can use a manual crank Harbor Freight bead roller, or Eastwood, or whatever, and you can put your beads in that way. You can also use like a Pull Max or something along those lines to put beads and stuff, and you really don't even need the bead roller. I do it for aesthetics, and it adds a little bit of strength to it, makes it pretty strong. So yeah, and then if you don't have a sheet metal brake to make these flanges, what you could do is you could use real thin angle iron to make a flange and weld it to it, like the back side, or you could just cut flat strips and weld it all in, or you could just not do a lip or a flange at all and just weld it all the way around the perimeter. Yeah, so if you guys have any questions on how I do this, or certain aspects of doing this, like the brake or the bead roll or the shrinker stretcher, the back side, making this flange, just leave them in the comments and I can touch on those individually. If you guys want to see other stuff, or whatever you would want to see as far as fabrication, or builds in the shop, I have a couple trucks I'm building right now. We can make videos on that. Like I said, this is my first YouTube. I've been wanting to do this for a long time, but I never really found the right time to do it. Now that I have a new shop at home, I have a little bit more free time to do stuff like this. Before, I was driving 35 minutes to my shop every day, and recently we just moved out here in the country and I built a brand new shop. Could also do like a shop tour video as soon as I get all my tools and everything in here set up. I still have quite a bit to get done in here, but we'll do a quick walk around. Got the CNC and the brake. Got shrinker stretcher, my press, stomp shear. I have another shear at the other shop I have to get. Customer's truck. This is my son's S10 that we picked up for 800 bucks that we're gonna build. We're using a customer's wheel for mock-up right now to get the link set up going. But this thing will be pretty cool. It'll be bagged with a 5.3 LS motor with a cam. This one over here, I did a bunch of sheet metal work on it. I'm finishing up the engine bay currently, and that'll be gone. And then, yeah, my bead roller, my welder, my other welder's at my other shop still. Slip roll, which I need to make a stand for, and just random shelving. And we'll go outside. So yeah, we moved out here in the sticks, which is great. But here's the new shop. It's 30 by 40 if you wanted to know. Yes, I wish I would have went bigger. No, I couldn't afford it. I have roughly $32,000 in this building without insulation, besides the double bubble on the roof. Got the big hexagon lights. Have another set right here that I can't plug in because I don't have a ladder tall enough. But yeah, I got plans. I'm gonna make a loft over here above these tools so I can put more tools and storage up top. I'm gonna put my compressor in the other garage over there, and plumb it so I don't have to hear the thing run in this metal building. Gonna do shelving all along this wall here, and then my lift will go right here where this truck's sitting. And then once I move this outside, I got another truck coming that I have at the shop that's gonna be on the frame table still. It's a crew cab body dropped full chassis S10. That's actually what those wheels go to. Those are custom one-off 20 by 12 American racing wheels. But other than that, that's it for the first YouTube video. I guess don't forget to like and subscribe. Shoot me a comment or message on what you'd like to see next. And I hope you guys found this video valuable and enjoyed it. Thanks.